Okay. Here in place of b, that is b minus c. So we can write this is w psi b minus c. Similarly, dilation property in place of f, bcf defined 1 upon c, f of c minus c upon c. Here, putting c by c equal to x, that is this, and after simplifying here, this one, so we adjust c, okay, under root c, multiply and divide here, and f of x minus psi x minus b upon c upon a by b. Okay, so in place of b, that is b by c, and in place of a by c. Okay, so 1 upon under root c, and this is in place of a under root c by c, that is we can write it. So we transform. Symmetry property. Okay, w psi f BA is equal to, this is as per the definition. So T minus B by A is equal to X. Here. So integral minus infinity to infinity, that is T is equal to AX plus B psi X bar A T equal to under root A integral minus infinity to infinity F of, we can adjust it, A common, and we can adjust minus b by a 1 upon a x minus b by this one, and conjugate complex of the conjugate of f of total and total conjugate. So this is this one. So conjugate complex of the w psi f w here in place of f, that is psi f, and in place of psi, that is f. Okay, so we can write w f psi. So this one is conjugate complex. Parity operator. PF defined already, P f of t equal to f of minus. So PFT P psi T minus B by A bar H. For definition, so this is f of minus T psi, and value of P psi, that is minus T minus B by A. So minus T is equal to X, that is here f of x psi x minus b by a. So wevlet transform of the parity function, that is anti-linearity. Linearity, in third part we discussed w psi alpha f plus beta f. Here we discuss anti alpha psi plus beta f. So here, as per the definition, f of t psi t minus b by a bar. This is the definition. Here, in place of psi, alpha psi plus beta f. Right? So this is alpha psi plus beta phi t minus b by a. So this is f of t psi t minus b by a bar dt, and this is yes, alpha bar. Okay, and second part. So antilinearity, this one is equal to alpha bar w psi f dk plus beta bar w phi f dk. And translation in psi, that is f of t in place of psi, that is t T psi T minus T by A. Value of the T psi TC psi is equal to psi T minus T by A minus T, that is B minus B. Simplifying this one, we have this one. Okay, so T minus B in place of B, that is B plus AC. So W psi F B plus AC. And next, direction is psi. Then wevlet transform defined as this, and 1 upon under root A minus infinity to infinity F R T G T psi T minus B by K R T, and 1 upon root A minus infinity to infinity, value of Tc 1 upon C, dividing this variable by C, T minus B by AC. Okay, so this can be written as, okay, this is C. So 1 upon C root A upon C psi T minus B by AC. Okay, so we can convert this. Okay, this is the under root C into under root C. That is under root C and adjust it 1 upon under root AC and this one. This is like 1 upon A psi B by T minus B by A. Okay, B by A here in place of A, that is AC. Okay, so W psi 1 upon under root C W psi at B here. Next, we have the definition. This one here. F is homogeneous function. Okay, so W psi F lambda A lambda B is equal to 1 upon, in place of a lambda A, 1 upon mod lambda A minus infinity to infinity F T psi C minus lambda B upon lambda A dt. Okay, okay, lambda C is equal to lambda X. Okay, so dt is equal to lambda dx. So we can write this. So this is F of lambda X. F is homogeneous function. Okay, homogeneous function of order n. So then this is lambda n of fx. Okay, value of this is lambda power n fx. Okay, and here lambda power n plus 1 and 1 lambda becomes the half lambda power. So it can be here lambda f of lambda x is equal to this one. Okay, value of this is in above equation. So we have this and solving this one. So lambda power minus half, so lambda power n plus half. Okay, suppose lambda greater than 2. Okay, so lambda power n plus half and w psi x. Partial identity. Partial identity of wevlet transform. If psi belonging to L2R and W psi at BA is the wevlet transform, F then or any function Fg belonging to L2R, we obtain this one. Okay. Here we know that what is the partial identity for Fourier transform. Okay, so here f cat omega and g cat omega j omega 1/2 pi, and this is f of t dt, that is this is 1/2 pi. Already written. F cat g cat is equal to f of. Okay. So here and inner product of the FG, okay, and here inner product of the FG Fourier transform, okay. So and here two variables B and A, okay. So and here in Fourier transform variable only frequency omega, okay. So here only one integral due to variable omega, single variable. Here two variables. So integrating this one. So and right side C side LG. This is already we have discussed the wevlet transform is the generalization of this Fourier transform. Means several behavior properties like to Fourier transform. Okay. So Fourier transform, that is integral transform. In integral transform, any for Hankel transform or any other transform, Parseval identity, that is integral with the transform of the two functions is equal to integral of the two functions. Okay, some constant. Okay, here constant C side. Here C side 1/2 pi. If we take the Fourier transform 1/√2 pi, that is 1. That is C side, in that case 1. Okay? In this case 1/2 pi. Clear? So, what is C side? You can see here. C side square, not Q, pi, and so on. Why? So, proof. You see here. W psi f TA, as per definition you can write this, as per already written technique, W psi f TA. And by Parseval identity of Fourier transform, you can write this 1/2 pi f cat psi cat. Okay? And already we have the value of psi cat dA already defined. This one. And 1/2 pi minus infinity to infinity. This one, conjugate complex of it for I b omega. This is the I b omega. And psi cat A omega bar B omega. Okay. Similarly, for G, here W psi F, because here we need W psi F and W psi G. Okay. So here we have defined with variable omega. This one, and similarly define G with another variable sigma. Okay. And left hand side of the Parseval identity of wevlet transform equal to putting the value of this and W psi F. Okay. So we have this one, 4 integral, 2 integral from here and 2 integral from this and Yes. We have this one. Okay. Why here? Is because here we need here conjugate complex. Okay. So here W side B A bar. I like this and conjugate complex of this, that is here minus is called IB sigma. Okay, and this is without of conjugate complex. Okay. This one. Okay. Here integration with respect to d omega d sigma dA dB. Okay, or integral or variable. So this can be one integral with this with respect to d. Already discussed. This one as a direct delta. Okay. And also know the property integral minus infinity to infinity f of x minus a delta x dx is equal to f of x. Okay. So this one with this. So replacing sigma by omega using the property of the delta function. So we have f cap omega, psi a cap omega, and g cap omega, and psi cap a. Clear? And this psi cap for a omega and psi a cap a omega bar. Okay? This is the psi cap a omega mod psi cap a omega. Okay, and with respect to a omega. So f cap omega, g cap omega, here the coefficient this. Okay, what is this? Suppose this is t side. Because here suppose a omega. Okay, a omega equal to t. Now you simply multiply omega and omega. Okay, that is same variable. No problem. So this is the value of this one, it's C side, constant. Depending on C side. Independent of omega. Okay, that is constant C side. From here, we have the additive data. Like coefficient B. If in Fourier transform, we have the coefficient this one, and wevlet transform, we have the coefficient this side. Clear? And then we have only integral minus infinity to infinity f cap omega g cap omega. Okay? This is 1 upon 2 pi. Using this property. This one. So we can write C side in the product of clear? So this is the proof. This one is equal to C side in the product of. Clear? Suppose here psi and psi. Here function different, f and g, but psi common. So we have the administrative condition, C psi is equal to this. But suppose psi, here psi 1, here psi 2. Then we have here necessary condition C psi equal to C1 psi 1 omega and psi 2 omega bar. If psi 1 psi 2 is same, that is psi mass psi square. Okay. So W psi 1 at W psi 2 G is equal to this. Inversion. Inverse wevlet transform. Inverse wevlet transform defined this. Okay, one upon C side and W side. Here, what is the inverse Fourier transform? Here, f of t is equal to 1 upon 2 pi minus infinity to infinity is power I omega t f of f cap omega d omega. Okay. Clear? F cap omega this one and this means here kernel is for minus I omega in inverse, this is a conjugate complex. Okay. So here ft is equal to w psi f. Here f cap omega Fourier transform of this. Okay. So here w psi f dA. Fourier transform is the Fourier transform of the function f, and here conjugate complex of the kernel. Okay. Kernel was in wevlet transform is psi dA bar. Here double bar, that is psi bar. Okay. We can compare with measure. Okay. So C psi f is equal to this and W psi f is equal to expanding the inner product. So this one and conjugate complex of this is dA and W psi f dA dC sin dA bar d dC dt. Okay. Value of this. Okay. dt sin dA bar. By definition of wevlet transform. Okay. Then GT bar and we can write this is ST integral. Okay. So integral like we can write and we take double integral with dB dA and one this one. Okay. So C psi ft is equal to we can write inner product of double integral of the function this one function and dt. Okay, so we can compare C psi fg. Okay, so we know that inner product alpha f g is equal to f alpha bar g. Okay, but here C psi here, so we can write this is C psi. No problem. C psi f and g is equal to this part and g. So C psi f is equal to this part. Okay. Then ft is equal to 1 upon C psi. Clear? Okay. is inversion formula. If f is equal to g, then this is the norm x square, and norm x square is equal to 1 g, and this is the right Plancher's identity. Okay. In Plancher's, that is f and g set are equivalent for Plancher's. For example, okay, already by theorem we had discussed the f convolution psi. Here phi t is scaling function. There phi is any integrable function. Okay, here phi defined. This is the father wavlet. Okay, so convolution generates a wavlet and psi t high wavlet. Solution phi x is equal to this, psi t is equal to r wavlet this one. Okay, and in convolution phi convolution psi is equal to integral psi t minus x dx. So we define psi t minus x, psi t already this one. So we can define psi t minus x, putting x simply in place of t minus x. So we can this t minus x in terms of value t minus x. So this is psi t minus x is equal to this one. Reverse here t minus x, we reverse. Okay, this is minus here and this can be minus half x minus t. Okay, so psi t minus x is equal to t this side and this side. So we have t minus half less than x less or equal to t, and minus 1 t minus 1 less than x less or equal to t minus half. Yes. Now the convolution of phi and psi is given by phi convolution psi is equal to this by definition of the convolution. So we break in 4 parts. Okay, so phi convolution psi t define this. So dividing in 4 integral minus infinity to t minus 1 to t minus half to t and t to infinity. Okay, right. So minus infinity to t minus 1 0. Here already defined only for t minus half to t and t minus 1 to t minus half, otherwise 0. So here minus infinity to t minus 1, t minus 1 to t, t minus half to t. So t minus 1 to t minus half, I psi t minus s and t minus half to t, I s psi t minus s ds, and in this interval, 0. Okay, so already discussed in theorem, that is wevlet. So here by putting some values, t is equal to 0. Suppose t is equal to 0, so we have this one, okay, minus 1 to minus half, and in this case that is value of size 0 and minus half to 0, this is also 0, that I have defined in 0 to 1. Ix scaling function, this is defined 0 to 1, that is 1, otherwise 0. Already we can see. So in that interval, 0. Yes, interval minus half minus 1 to minus half. Okay, so 0 and minus half to 0 also 0. And t is equal to 1 by 2, that is value of this is equal to again minus half to 0 and 0 to half. In 0 to half, hypermotion phi in defined interval 0 to 1, it means 0 to half also 1. Okay, so psi t high and psi value you can put, that is 1. Okay, already defined. You can put t, value of t in this and in this also. Okay, so you can compare and compare. I half is equal to half. Similarly, at t equal to 1, interval 0 to half and half to 1. So we can take the value from there and put here. Okay, so this is 0. Again, at t by 2, this is minus half. At t is equal to 2, this is 0. Okay, and some other value t is equal to 1 by 4, t is equal to 3 by 4, and t is equal to 5 by 4, and so on. At t is equal to 7 by 4, minus 4. Okay, so putting the 0 to 1, 1 by 4, and 1 to 2, minus 1 by 4, so figure as like this. 1 by 4 here, minus 1 by 4 here, and half minus half, so this is like the wevlet. Here is the wevlet. Yes. We can check by administrative condition also. So Administrative is the Fourier transform of phi, Fourier transform of psi. That is Fourier convolution of Fourier transform of phi convolution psi. That is Fourier transform of phi, Fourier transform of psi. We can put here and Fourier transform of scaling function is defined this one, and Fourier transform of R wavlet defined yes, you can calculate easily. So the value of psi and psi is this is 0 to half, half to 1 and so on. It is value this and solving this we get this one. Okay, so this is this are equal to this. This is hard function. Okay. So by properties also satisfied, and by putting the value also you can see the figure. Okay, that is it. And the next example is R wavlet where phi t scaling function is Gaussian function. Rho minus t square. Okay, so psi t R wavlet and psi t minus x as earlier we can define t minus x, putting x minus t and so on. Okay, so I did Gaussian function. So psi convolution phi is equal to phi x psi t minus x and as earlier t minus 1 to t minus r, t minus r to t at t equal to 0. This is we have this one and putting the value t. So it is approximate point. Similarly, at t equal to 1,
2.7.
we have this one and this is minus. Similarly, at t equal to minus 1, this and we have at t equal to 2, so this is minus 1. At t equal to minus 2, and so on. Okay? And figure we can draw. Is it similarly? And the total side is equal to get by admissibility condition. Okay, so we can take also from admissibility condition. This is a long process. That is that if you take this one and solvent this, so it will take more time. Okay, so it is better we can check by admissibility condition. Clear? So admissibility condition, Fourier transform of the phi convolution psi which is well known. Fourier transform of phi to Fourier transform of psi. And phi t is one minus t square. Already we know that the Gaussian Fourier transform of Gaussian function is Gaussian function. So phi cat equal to this one. Okay, so n cat equal to this one. Okay, and So C theta is equal to C theta is equal to theta cat omega upon mod omega d omega. Clear? And putting the value of theta at this one here, since the hard wavelet is admissible, so here tends to 0. Okay? So this is psi cat equal is greater than 10. Okay, so hence identity condition. Okay, so a mathematical point of view, the continuous representation of function depending on the parameter here. Okay, so it can be converted into this. Each one by assuming A and B take only integral part. Okay, A and B integral. So here, first we fix two positive constants A0 and B0 and define psi mn is equal to A0 or minus m by 2 and psi A0 or minus m3 and B0. Where mn belonging to Z, that is integer. And f, Z or f belonging to L2 are the discrete wavelet coefficient as inner product of S psi n. Okay? What is wavelet transfer? Wavelet transfer and W psi S inner product of S psi 0. Okay? That is the coefficient constant. Okay? This one is the wavelet. So discrete wavelet transform defined this. In that case, that is the AB. Okay? Here, m the only integral value. And W psi S mn defines this one where m and n integral value. Okay? So suppose m and n 0. Then psi 0 0 3 is equal to psi 3. Clear? For computational efficiency, A0 is equal to 2 and B0 is equal to 1. Evaluated for computational efficiency. A0 is equal to 2 and B0 is equal to 1. Are commonly used. Then A is equal to 2 to the power m and B is equal to n to the power n. Okay, already defined A and B in terms of A0 and B0. Okay, so putting this value there, here. So psi mnt is equal to 2 to the power minus m by 2 psi 2 to the power minus n b minus n. Clear? Yes, I have putting the value of A0 and B0. A0 is equal to 2 and B0 is equal to 1. Where here why we take 2 to the power m by 2. This is this factor 2 to the power m by 2 ensures the orthogonality. Okay, I will show. Yeah. A wevlet definition. Psi belonging to L2R is called orthonormal if the family of functions psi m generated from psi by equation 1. This is the generated from psi. And orthonormal family psi m satisfies psi inner product of psi m and psi k is equal to psi m and psi k x dx. Okay, generally we take bar. Okay, so we can ignore here because here psi no problem, you can take but generally in real case, however, that is real, so you can. So psi m and psi kl, okay, this can be written as delta mk delta nl. But this is delta mk, it is a Kronecker delta. Kronecker delta defined by this. Delta mk is equal to 1, if m equal to k and m not equal to k, that is 0. Okay, so lemma, if psi and phi belonging to L2R, then psi mk psi phi ml. Okay, here psi and phi different. Okay, then psi mk phi ml is equal to psi mk phi nl. Then normal psi ml is equal to and normal psi ml is equal to normal psi. Why? Here the same formula means this shows that the inner product does not depend on the skill level. This dilation does not depend. Okay? So not depends on the scale. Meaning of this. Okay? So when both functions are dilated equally. Proof psi ml, phi ml is equal to this one, putting the value of psi and phi. 2 to the power m, psi to the power mf minus k, and value of this phi. Here defined phi psi, phi x is equal to 2 to the power m by 2 and phi 2 to the power m, x minus phi mn. Okay, so same psi also. Here psi, here psi. So 2 to the power m by 2 into 2 to the power m by 2, that is 2 to the power m. So here 2 to the power m. Okay, so which is, let 2 to the power mx is equal to 2 to the power n t. That is 2 to the power n by 2, here 2 to the power n by 2, here s here, and we have this result again psi in terms of n, psi n k by 2. So here it means that the inner product does not depend on the scale. When both functions are dilated equally. If we have same, that is and normal psi mn star, this is putting the value of psi mn and psi mn here also this is the permutation of the conjugate complex. So to this one and this is psi t bar. Okay. null psi. So null psi mn equal to null psi. Wevlet series. Okay. In Fourier series, complex form of Fourier series, we have seen fx is equal to summation n Cn and e to the power I n pi x by l. That is the kernel. Okay. So here and Cn is equal to there is a Fourier transform of unconductive C omega. So here Cmn, this is your Wevlet coefficient. Okay, and this is the kernel Wevlet transform. So here Cmn, this is the coefficient and also known as the Wevlet transform. Okay, so as for Fourier series, we can define the Wevlet series. Here, double series, depending on m and n. The meaning of this is one summation more. Simplest example of an orthonormal wavelet is classic hard wavelet. Psi x is equal to this one and psi mn psi kl, putting the value of psi mn psi kl and this one here r m is equal to k. After simplifying, we have this result. Any problem? Yes? Okay. So here we have the result, this one. R m is equal to k. This result gives psi mn psi ml. M is equal to k. M is equal to k, that is this is the part 0. Okay, so this is also 0. So we have the value. This one is equal to psi t plus n minus n t. Then as per definition earlier, this is defined. Here no 2 to the power 0 and psi t to the power m minus something, that is 0 0. And here also to the power something that is 0 and we have t this one. So this is L minus t minus L minus. So we can write this. Okay. Fine. Here. And perfect. Okay. So delta 0 L minus L or delta 0 L minus L, this can be written as delta L. Okay. Is clear? Where psi t not equal to 0, in this interval 0 to 1. and side T minus L minus L bracket. Okay. Yes. So in this is not equal to 0 in this interval, T minus L less or equal to 1. Okay, so that is in L minus N less or equal to T less or equal to 1 plus L. Okay, from this side and this one at this side. Okay, so here this interval and the intervals are different. We now consider the case M not equal to K. That is the case of M equal to K. Here we have this equation. If M equal to K and another case M not equal to K. Okay. In view of symmetry, it suffices to consider K greater than M. M not equal to K, suppose K greater than M. Putting R is equal to K minus M greater than 0 in equation 4. Okay, we can complete the proof by showing that K not equal to M at like this. Where here after simplifying, we denote this. Here, where S is equal to 2 to the power R N. In view of the definition of R-wevlet size, we must prove that integral phi vanishes for K not equal to M. In other words, it suffices to show that 0 to half this, okay, and half to 1 this one. Yes, I see na. So minus half minus infinity to 0, 0 to half, half to 1 and 1 to infinity. Okay, minus infinity to 0, that is side 0. Okay, and 1 to infinity also 0. Okay, in interval 0 to half, side T is 1 and half to 1 minus 1. So we have the result, putting the value of side T, we have the result this. Clear? So this one is equal to 0. So let 2 to the power RT plus X is S equal to X. Then dt is equal to this one, and that integral can be written in this form. Clear? Suppose this is A. Okay? S plus 2 or minus A. And this is A B. It means this is the integral S to A and A to B. Okay? Psi x, dx, psi x is equal to 0. Why? Because this is the compact support between 0 to 1. Okay? So, this simple argument that yes, A contains the support 0 to 1 of psi. Okay? Suppose we convert this, okay, yes to 0, 0 to half, half to 1, 1 to 8. Okay, so value of this one and this one same is done. Okay, so what is this? Then is the R-wevlet size is friends. So a sequence phi L is Hilbert space H is called a frame if there exists constants AB greater than 0 such that A norm F square summation then equal to 1 to infinity mod of the inner product of F I n square that is equal to B norm square. The constant A and B are called frame. If A is equal to B, this is tight frame. If A is equal to B is equal to 1, it becomes orthogonal frame. That is, now F is if A is equal to B is equal to 1, means this is norm F square that are equal to this, and this is also that are equal to norm F square. It means norm F square is equal to this. It is known as orthogonal frame. For example, if En is an orthonormal matrix, then E1, E1, E2, E2, E3, E3, and so on is a tight frame with frame bound A is equal to 2 equal to 3. And this example under 2 E1 is an exact but not a tight frame, then the frame bounds are A equal to 1. The frame is called exact if it ceases to be frame. Okay? If frame property ceases, not properly defined, that is exact. Okay? So this is an exact. And this is tight frame with frame bound this but not orthonormal. And this is a complete orthonormal sequence but not a frame. Okay. So for any x belonging to S, En is an orthonormal basis. We have x is equal to this one behind norm x square. Suppose here okay, so here x, x. So this is if expanding this one and simplifying this, then we have summation x En and this is En x. Okay, so this is x En. And this is x En bar. This is summation mod x En. Okay, so norm x square is equal to where x is equal to x1, x2, and so on, xn. Okay. Xn and so on, if infinite dimension, that is and so on, n dimension, that is. So here x e inner product of x En square is equal to, we can expand this way, n equal to 1, 2 and so on. E1 is equal to 1, 0, 0. E2 is equal to 0, 1, 0, 0. E3 is equal to 0, 0, 1, 0, 0 and so on. So yes, E for inner product of x E1, that is x1, x2 and so on, it is 1, 0, 0, and multiplying x1 into 1, x2 into 0, x3 into 0, and so on. That is, we have x1. Okay. So from here we have x1 square. This square, that is x1 square. From this x2 square, and so on. That is xn, and so on. That is normal. Okay. Clear? So this one we have E1, E1, E2, E2. Are these normal square? Are these also normal square? That is total 2 normal square. Okay. So norm x, norm this one is equal to norm 2x square. Okay. Norm 2x square, that is a is equal to b equal to 1. That is that. It is type same, it a equal to b is equal to 2, but not exact. Okay, why not exact? Suppose we destroy one element from the given structure. We have E1, E1, E2, E2, and so on. Suppose we remove one, E1, none. Okay, so we have E1, E2, E2, E3, E3, and so on. Okay, so we have only this part, x1 square and x2 square plus x2 square. We have 2 E2, 2 E3, but E1 1. So from E1 we have only x1 square. Okay, and this one. So x1 square plus 2 x2 square. Can we write in the null? Can we write? No. Okay. So this destroys the same property. But this is less or equal to suppose we can add one x1 square. That is less or equal to here x1 is this one, it is equal. If we add one x1 square, that is less or equal. Okay, so we can clear. So this is 2 normal x square. So right side 2 normal x square. Okay, and this one less or equal to 2 normal x square, and we have this. Okay, if you remove one x2 square and x3 square and so on, it means this is not equal. So this part less or equal to this part. Okay, so we can write this. Here, so here a is equal to 1, b is equal to 2. That is clear. Not exact, but okay. Okay, so this is the same property. Therefore, it is not exact. Clear? So similarly, we can solve another part. Okay. Discrete Haar wevlet. Okay. So Haar wevlet.
So certainly
So psi MNT defined this. Already we have discussed. And psi t defined 1 lies between 0 to half and minus 1 lies between half to 1. Okay. So in place of t, this is 2 to the power minus m, t minus m. Okay. So putting this value in the hard wevlet and simplifying, we get 2 to the power minus n by 2 and 1 in this interval. Is clear or not? Clear? Putting this is one zero to t less or equal to 0 to half and half to 1. In general, this is not equal, but you can here taken equal or not. Okay. So this is clear? Putting here side t. So t putting here 2 to the power minus n t minus n. So in place of t 2 to the power minus n t here also, and we can adjust. Clear? Already discussed earlier. Okay. So this one and 2t minus 2 to the power minus mt minus n. This side 0. Okay. Psi 2 to the power minus m n t minus n t minus n. Okay, 1 and this is 0 less or equal to 2 to the power minus mt minus n less than half. Okay, suppose this is, we can write half %. Okay, and dividing both sides to the power n. So we get clear? Yes. So psi mn is equal to this one. Yeah, here explain. Already explanation given. Okay. Then ft is equal to this and this is and the coefficient satisfies the strength condition a is equal to b is equal to 1 by that is this one is satisfies the condition a is equal to b. 1. Proof is assume ft is equal to this lies between 0 to half a and half to 1 b, otherwise 0. Okay, so inner product of f psi mn is equal to 0. Okay, r m less than 0, n not equal to 0. We can check easily. R m is equal to minus 1 and a is equal to 1. You can check. Okay, very simple order property. Okay, we now take m belonging to n0 and fix n is equal to 0. Then I f psi 0 0 in a product of that is half of a minus t. Okay. This is the inner product of minus infinity to infinity. Okay, you can break. This is 0 to half, half to 1, and otherwise 0. Okay, already value of f in this interval and psi also. Okay, so is it clear? So yes, psi 0 inner product of this is equal to half a minus b, and inner product of f psi 1 0 is equal to this, and I give that again. So psi f psi 2 0 is equal to this, 1 by root 2, 1 by root 2 square, 1 by root 2 cube, and so on. This is the same. Only for different f psi 0 is. Yes. In general, inner product of f psi n 0 is equal to 1 upon under root 2 power n. 1 upon under 2, next under root 2 square, and so on. So, consequently, our wevlet series f psi 0 0 and psi 0 0 3 is equal to this in this interval and minus of this in this interval. Clear? Are n greater or equal to 1, psi n 0, this is for 0 0. Here n greater or equal to 1, this one, and therefore our wevlet series, this part, okay, is 2 to the power minus m a by 2 plus b by 2 in interval t belonging to 0 to 1. Then wevlet series psi f psi n 0 and psi n 0 t. We have this one, adding both are zeros. Already I have the value. This part are 0 0, m equal to 0. Okay. And greater than m greater equal to 1 is this. Finally, value of this one is this one. Clear? Here summation 2 to the power minus m. Value of 2 to the power summation 2 to the power minus m is equal to 1. Okay? By geometric reason. Therefore, the above reduces to this one. A to B, 0 to half में, this is 1 आ जाएगा, this is 1, and simplifying this one, this is A and this is A. So, moreover, now of mod of the inner product of f psi n 0. So for 0 0 this one, and from n equal to 1 to infinity this. Okay, so putting the value of this one, already defined value this a by 2 minus b by 2. Okay, and the value of this are first part 1 upon 2 into this, and second part 1 upon under root 2. Okay, and second part under root 2 square, 1 upon under root 2 square, and second part 1 upon under root 2 cube, cube, and so on. So here square, putting the value of this is the common, and this. Okay, so again value of this is 1 to the power minus 1. Okay, so value of this is 1, and this is 1 upon 2 a square plus b square. Okay, so you can write f square t because we have defined norm f square. Okay, so norm f square is equal to what is this? This is a equal to b equal to 1. That's it. Okay. Okay. Right, okay. Okay. Any question? The slide or slide?
Those kind
Can
of
I complete? Okay. Okay. I finish within 5. Okay. This is the frame operator. This is the frame operator defined by the corresponding operator F denoted by and reconstruction formula behind this and theorem if f is same then f is linear always reference line operator and inverted its inverse also bounded operator. Okay, and behind
nanti usah PDF ada kelang print out दिखाना
yes.
wevlet
Linear
पूरा
property
concept है सब
जब
क्षेत्र में
अल्फा x पर
इसे
बीटा
लाइव
g
चला
Yes.
मिलेगा ग्रुप में
Same operator defined.
मिलेगा
So it is the value of f in case of alpha x plus beta g.
जो काम हुआ
So yeah, this one I kept defined it. Two parts, that is alpha f and beta f, that is the linear and bounded alpha f is equal to this one and this is just notation. Okay, you have to just notation. So as per we have defined this one r x square. So as per this, we can this one is equal to a norm of f square is equal to this one. Okay, so that is by the definition of same, we can write this and this can be written as f of f. Okay, f norm of f square is equal to this one. Here one time defined x is equal to without this. Okay, so same like here f of f is equal to this and with inner product f of f and f. Similarly, a and f. Okay, I and f. So we have this one. Clear? And a normal f square. Putting the value of this one, f of f. Okay. So this can be written if, f, here. So this is AIF, FF, EIF, this one, so AIF, FF. This is the form. So when we set pipeline, f of f is defined, value of FF this and T, and this can be written as this is inner product of this one, and we can reverse this and get
ये वाला फील्ड ठीक रहेगा,
this is the
ठीक है।
coefficient. So this can be written as summation. We can expand and simplify. Okay. So we can write this is S and summation with this and this is with this one. Okay. We know the inner product of alpha x y is equal to x alpha bar. Okay. So alpha bar inside that is. Okay, so this one we can write, and this is F R. So F R F D equal to F into F R. Okay, and F is positive. F R F is equal to D, and simplifying D, this is the mod F is positive, mod always better are equal to 0. That is sum of positive number. That is so F R F. Invertible, this is the invertible property that is defined. In the differences.
थैंक यू सर।
Thank you, sir, for the wonderful session. Now, I would like to call Dr. Vasim from Department of Mathematics, IIT Patna, and Rajiv Ranjan from CPEC to kindly present a token of appreciation to our students.
Thank you, sir. Thank you, sir. No any question. No any question. Question. Online participation. Bus is waiting in the. One.
सर आप कहाँ से हैं? आप
मोबाइल में
भेज दीजिएगा हमको।
ठीक है, दे दीजिएगा बाद में। अच्छा सा एक लाइट चला रहा है।
आपका कब सबमिशन हो रहा है भैया? आपका कब? हाँ
क्या करेंगे?
आगे निकल जाना है, धीरे चलोगे ना तो वहाँ लाइन ज़्यादा खड़ा होना होगा। आज हम लोग पीछे हैं।
हाँ, लाइन में इधर से ना हम लोग आते हैं।
Get ready. Get ready.
हाँ हाँ
कोई दिक्कत नहीं है, 10 दिन और दौड़ लेंगे, 2 राउंड और लगा लेंगे।
रोटी नहीं खा चावल लेना रोटी नहीं खा तो चावल लेना ज़्यादा नहीं है।
हाँ? कहाँ है? कहाँ जाएंगे? भैया तो क्या करें? अब बदमाशी नहीं करेंगे।
पटना में जाना है। तीन बोल रहे हैं, दो पीस बोला। हाँ 2 पीस। करे मैडम को दे दो
एक सब्जी रिप्लेस हो गया
सब्जी का सब्जी है
लौकी लौकी जगह सब्जी रिप्लेस हुआ अभी कहीं सब्जी आ लौकी लौकी से इनके ठीक है इनके लिए
आज ना जाएंगे मैंने खा लिया कितना हुआ
2:01
साला बजिए गया था ठंडा हो गया
वो गए क्या रूम में? वो चले गए? अच्छा रूम पे जा रहे हैं, अपने रूम आ रहे हैं पास। ये मेरा कैमरा है। मेरे पास अब चल रहा है, बस आ गई। इसमें इतना सारा पेट्रोल है। जा रहे हैं, बस आ गई है। तो आप लोग को चलिए बनते रहिए, देखते रहिए। उधर दिखा रहे हैं आप लोग को।
इस पर असर नहीं करेगा। गेट कब तक बंद कर दीजिएगा? यहाँ तो आना चाहिए हमेशा तो बस आएगी यहाँ वाला
ये मैसेज क्या आया है? ऑन द Pacific अभी हटा के क्या लाइव चला
पार्टी से सब आ जाए लाइक
सेक्शन करना हो New.